Hi everyone and welcome. I'm Anine van Deventer and it's a pleasure to welcome you back to another LabFind activation session. Thank you for making the time to join us today. One of the questions we've been exploring over the past few weeks is why do laboratories often discover operational problems after they've already affected turnaround time, quality, or cost? Laboratories have plenty of data. They use it for monitoring KPIs, quality indicators, and compliance measures. Yet, despite all that information, issues still seem to catch us by surprise. That is what today's discussion is all about. Our guest speaker, Dr. Zaid Naima, will unpack why laboratories often see errors too late, and more importantly, how we can use operational data to help us reveal early warning signals before those issues become major operational problems. As always, we'd like this to be an interactive session, so please post your questions in the Q&A as we go. We will reserve time at the end for discussion. And with that, it's my pleasure to welcome back Dr. Zaid Naima from UI Health in Chicago. Zaid, over to you.
Good morning, good evening, and good afternoon, everybody. Thank you for joining us, and we'll get started here in minus 5 seconds. I'll go ahead and share my slides. And let us know in the chat where you're from. We'd love to see how global we are now. So today's talk is going to be a really interesting one. One of the things oftentimes I notice in the lab is we find the error a bit too late. The reagents might have already been consumed. We're doing an RCA, a root cause analysis, and we're scratching our head saying, if only we could have found this error sooner instead of weeks or sometimes months. And as everybody knows, these results we send out to patients impact patient care. About 70 to 80% of decisions by a provider is based on some kind of a lab test. So it's extremely important that we send accurate results and we identify any errors early on. So the word I really want to stress here is operational intelligence. So you want to make an informed decision and you want to make it as quickly as possible and really be able to proactively identify these issues. So what are we covering today? 4 big themes here. First one is how operational problems often stay hidden. So they stay under the radar. They're under what you're noticing. So they're almost invisible. And we're going to teach you how to bring these up to the surface, how you actually can see them and make them visible, and how to act on them. Also, we're going to explain lagging indicators. So lagging indicators are your run-of-the-mill quality indicators. So your turnaround time, corrected reports, traditional KPIs. And we're going to find that difference between those indicators and the leading indicators. And again, that goes into that operational signals, the cue, the flow, the variation in the data, and how we can act on this early on to really identify these issues. And we have some examples for you. And at the end, we'll give you a blueprint, a 90-day blueprint that you can start this coming Monday if you want to. So let's make a case for this. Why should we do an early discovery? What's the important here? And why is it something we should learn and implement in our lab? So I really want to first say the goal is not more data. Every lab has a plethora of data. And the question is more data going to be helpful? In most cases, that data will bog you down. There's something called analysis paralysis, meaning you're stuck analyzing the data without acting. So this is, again, where that lag shows up. You have metrics that react a bit too late. Again, sometimes you might experience that you find an issue a week or 2 weeks or even a month after that you notice these issues are coming up. The QC was out a week earlier. The instrument out of nowhere went down and now you're scrambling to fix the instrument. And again, watching that operations. So you want to watch for those variations, and we'll give you very specific examples about that. And then you want to understand the signal came first. Again, the key word here is that those signals are hidden. and our job is to make them visible. And you want to design for these issues to surface. Those signals, you want them to be able to actually come up to the surface and then act on them. So the goal is, again, is to have meaningful signals, and you want to review them early enough to act on them. One of the things we really want to explore today is, again, seeing that lag, shifting the lens, and then reading those signals. And again, creating a way to bring these up to the surface is going to save you turnaround time, the workflow, the cost, or even really patient care. At the end of the day, if you're sending results out and those results may not be correct, and then you're having to do a lot of rework, you have to go back, rerun samples, you have to send corrected results. So that oftentimes erodes that trust that you have with your patients, with your providers, the nursing team. If they don't trust those results, they may not trust you, and that could really impact the reputation of a lab. And again, we want to move from compliance and quality systems to actual design of an operational system that brings those issues to the surface. So again, the key word here is bringing those invisible signals up to the surface and acting on them. And again, being able to read those signals. So we'll have a slide for you where we'll have about 9 or so scenarios, what to look for, what the issue might be, and how to really identify it in an effective manner. So before we dive in, how early would you catch it today? So we'll have a poll for you, and if you want to, we'll give you about 30 seconds or so to answer it. So just be very honest. There's no wrong answers here. Just let me know, how soon would you catch it? Would you catch it a bit too late? Are you one of those people who already knows that there's an issue and you catch it immediately? If you are, kudos to you. So let's see, the results are coming in. Okay, so it looks like we have about 54% would catch it late, followed with we would catch it early, about 33%, and let's see, 5% said we would miss it, and 8% we would catch it instantly. So those 5 individuals, great job. You're catching it early on. So this slide really sums up this entire talk, and I think this is really important for us to kind of slow down and really examine this. So traditionally, when we're discovering an issue, we're stuck between number 4 and 5. So I want you to put your thinking cap on and think through this. You notice that the turnaround time is now spiked up. What should take an hour is now taking 2 hours. So that quality metric is now in the red or in the yellow. And you being the diligent lab tech, lab supervisor, manager, even director, you say, well, let's do a root cause analysis, an RCA. And you get your paper out and you start looking onto, is the issue tied to the technicians? Is it an SOP gap? Is it an instrument issue? Is it a reagent issue? And I want you to think back when you did an RCA, how long did it take you to get all the data, all the information? I bet it took quite a bit of time. And if you think about it, that issue that you're trying to fix or you're trying to understand probably was going on for 2 to 3 weeks before you created that root cause analysis. And if you want to share in the chat how long it took you to do an RCA, a root cause analysis, I would love to hear that and see that. So again, traditionally, we're doing that investigation between 4 and 5. So if you want to shift your focus to step 1 through 3, the problem is already active, but it's invisible. The QC is actually trending up. The turnaround time is actually trending up, but it's still green. It still looks fine on the surface. The instrument is creating a lot of flags, a lot of issues, but you're not acting on it because it's invisible. The variation starts accumulating. If you worked in any lab that has different shifts, a morning shift, an afternoon shift, an evening shift, a night shift, you probably notice that sometimes each shift does things slightly different. The morning shift might batch samples. The night shift might actually just process samples as they come. So those small variations starts forming between each shift, which causes slight differences, enough where it's changing the turnaround time, it's changing the results, but not for you to notice. And again, this is where the cost will increase. For example, if your night shift is running QC multiple times instead of one time, and they keep repeating the QC until it passes. Or the turnaround time, it's actually higher on one shift versus the other. And of course, a backlog. If you ever have to come into your shift and you have 50, 100 samples from the shift prior, you have to work on getting all those samples cleaned up, resulted, and then you start your work. So again, there's a lot of things going on here between step 1 and 3 before that quality metric actually goes into the yellow or even into the red. So we have to shift our focus to that 1 through 3 instead of traditional issues where you act upon a quality indicator when it's yellow or red. Now, we need to understand, why are traditional indicators lagging? What is the issue? If it's an indicator that we've been using and it's a common theme, a common indicator that we use in the industry, why is it not robust enough? Well, we spoke about how QC failures and incident reports are lagging by nature. So it's not in real time that you're noticing these issues. It takes a bit of time for you to notice that the QC is drifting. It might be a day or two that you go back and you're reviewing your QC, and you'll notice that QC is actually trending up. So if you're familiar with Westgard rules, you might have noticed that there was a few spikes on the second shift, for example, for potassium, for electrolytes, and it went under the radar. There's again, a gradual drift. We as people naturally tend to sometimes not follow the SOP, the policy that's in place. You might have a tech or two who say, well, I should mix the reagent 5 times, but I don't have time. I'll take the sample or the reagent out of the fridge and immediately put it on the instrument. That may not impact it immediately, but repeating that over and over, that reagent isn't mixed properly, it's not suspended properly, it will eventually create a drift in the process. You'll notice the QC is slightly lower or higher depending on the assay or the test you're doing. And the green while eroding. So you can have your quality metric dashboard completely green. Things look great. The medical director is happy. The hospital is happy. The techs are saying, all right, we're doing great. Everything is green. But again, we spoke about how sometimes these issues are in the background. And it's very difficult to get them up to the surface if you're not comfortable looking at these at a deeper level. And impact before escalation. I bet everybody here had an instrument that out of nowhere went down. It was working just fine an hour ago, and then it stopped working. An error came up, error E01, and you're scratching your head. Well, I did the maintenance, I did the daily maintenance, I did the weekly maintenance. The results all look fine, but why is the instrument not working? And it could be simple as the probe might have crashed or the belt might have been loose. A lot of these issues are, again, invisible by the time they surface. So you want to be more proactive versus reactive. And oftentimes the patients feel that. Again, 70 to 80% of a decision, a clinical decision, is based on a lab test. So the physicians, the providers, the doctors, they're making a lot of their judgments, their treatment, the course of care for the patient based on the results that we produce, that the lab produces. So it's extremely important that we're getting the best results out there. So what are some of these common hidden failure modes? I try to kind of sum it up, and of course, this is not an exhaustive list. This is just the top 5 that I believe should be really looked at. Specimen routing bottlenecks. So sometimes when you're getting hundreds of samples in a day, those samples will stall somewhere in the workflow. And if you step back and you kind of watch where those samples are sitting, sometimes you might notice these samples are coming in from the phlebotomy team. They'll sit on the benchtop for maybe sometimes half an hour to an hour before somebody touches them. Or the courier that's bringing in the samples might accidentally put them on the wrong shelf of the fridge. So instead of putting it on the top shelf, they put it on the bottom shelf. And those samples go missing for half an hour before somebody finds them. Workload imbalance across instruments. Sometimes we have our favorite instrument. I know I definitely had a lot my favorite instruments that I liked more than others. So let's think about a chemistry analyzer. If you have two chemistry analyzers, are you using one instrument more than the other? I want you to go back to the lab next time and notice which instrument is used heavily. Staffing mismatched. We all been in a position where you might only have two people on the weekend shift or three people on the night shift, while the morning shift might have five. So that mismatch, that imbalance of staffing can cause a lot of variation. People will try to get all their work done with less people, and sometimes they're not following that policy, that procedure. And we talked a little bit about growing rework and repeat testing. I've been in positions where I recall techs, the QC failed, and we kept repeating it until it passes, and we don't really say anything. We don't escalate it up to the supervisor. Again, this is hidden under rework that's not seen. And then escalating queues times 15 steps. Next time you're in the lab, I want you to take a timer and see how long does each step take, and then write it down. How long does it take for the samples to be accessioned and brought into your lab? How long does it take for those samples to sit there before they get moved to the section that need to be tested? Take a pen and paper, write those down, and then go back and review it and say, wow, I didn't realize the samples sat there for 15 minutes, 10 minutes before somebody touched them. Again, these gaps are sometimes hidden because the results are still coming out. The turnaround time is great, but it could be better. So let's put a dollar figure, the cost of finding out too late. So let's start off with the most important thing, which is patient care. Again, we're patient-centric. Our patients are family members. It could be your brother, your sister, your father, or your mother. So it's always good to make sure you are providing the best care. So the results can land after care has changed. So by the time you fix the instrument and you bring it up, the physician might have already given the medication, or they might have transferred the patient to another hospital. Or worse, they might have collected the sample and sent it out to another clinic because of an issue you're experiencing in the lab. The turnaround time, again, it's quietly creeping up. It's taking longer and longer to get results out. And waste, you're repeating more samples, you're repeating testing, the reagents you're using, that's all costing more money. And then the overtime, your staff might have to stay late to catch up because of the backlog, because they have to troubleshoot more. And then importantly, the confidence. We spoke about how these issues can cause the hospital to lose confidence in you as a lab. It can create issues where people are really saying, well, they've been giving us false results or they have incorrect results. I don't know if I trust my lab. Maybe I should send it out somewhere else. And of course, those samples being sent out do cost money. And then, of course, our people, the lab techs in the lab, they're constantly running around trying to put out these fires. They're firefighters. They immediately see an instrument down and everybody's running over to get it fixed and get it up and running instead of focusing on the work. So I want you to think of cost as a function of time to discovery. So the longer it takes for you to discover the issue, the more it costs for you. So again, the longer the problem stays invisible, it takes longer to resolve. So again, I want you to think about the last time you had an issue and how long the issue was and how long it took you to solve that particular problem. So I try to kind of pull a few signals that you should start monitoring. Of course, you don't have to monitor all these signals, but these are some of the top ones that definitely deserve a spotlight. So we spoke about the queue length by step, taking a watch, a stopwatch, and then seeing where that delay is. starting the watch and seeing how long it takes to get the sample into the lab, from the lab to the testing, and from testing to resulting. So I'll give you guys a little secret pop quiz, so to speak. If you know the 3 phases of the lab, I want you to put it in the chat for me. So there's 3 distinct phases in the lab. We'll come back to the end and see if you guys got them right. Time and status, how long a sample waits at each stage. So again, if the sample is sitting in a queue and nobody's touching it, the clock is still going. If you have an hour to get a stat results out, but the sample is just sitting there, it's not being worked on. We talked about instrument utilization. Again, I want you to go back next time in the lab and see which instrument is used more than the other. Is one instrument sitting idle? And why is it sitting idle? Is it maybe further away? Maybe people just don't like using that instrument because it creates a lot of issues. And then rework and handoff. I want you to start keeping track of how often we do rework. We have to go back and reprocess samples because the results were incorrect. And then demand versus capacity. Do you have enough staff when the volume hits? Most hospitals, they have something called a morning draw. So that occurs sometimes between the hours of 4 and 6 in the morning. This is when phlebotomy team, the nursing team are coming in, they're drawing samples, and they're sending it to the lab. So next time, see when that spike of samples are coming into your lab. Do you have your staff positioned correctly? And now let's go into some working examples. So this is a really interesting example because at the very top, you'll notice the turnaround time is fine, but your 90th percentile, which is the 10% slowest samples, are actually climbing up. So this is a good example where you're monitoring the blue line, the median. It looks fine, but your top 10 slowest samples are actually creeping up week over week. So this is a signal came first. So if you're looking at those samples, you'll notice that issue. Let's look at another example, workflow bottleneck. So the signal here is between the 2 stations. Again, I want you to think about you have 2 analyzers, and in the station in between, samples are actually taking longer to get queued up and put on. So again, you may not notice it because results are coming out. There's no issue there. You say, well, we're still hitting the turnaround time, just like in the earlier slide, but slowly it's building up. And then an instrument goes down and you immediately have a huge backlog. So again, watch the flow, not just the final results. So you really want to watch the entire journey and not just when the results are sent out. So how do we design this system? What are the steps we can do to have this operational intelligence system? Well, first, you have to track leading indicators, and we'll have a slide about what those are. You want to visualize the workflow live. So you need to spend time looking at each visible step in real time. So again, going in the lab, having that stopwatch, writing down what is the workflow. And then you want to start monitoring for variation. Remember, if you have 3 shifts, is each shift doing the workflow the same, or is it different? And then let's shift our focus to, again, that early discovery zone. When it's too late and you're operating between zone 3 and 5, you're already being reactive instead of proactive. So again, you want to look for those small variations. The operational stress, where are those coming from? Your WIP, work in progress. How many samples do you have that are in that work queue? And then as you go into step 3, 4, and 5, you're going into it with more signals, more understanding of what's causing the issue. And before it becomes a big issue where the team is trying to figure out and solve it, you already did that work up ahead in step 1 and 2. Now, what are these leading signals and how can we capitalize on them? So I try to kind of break them down again into digestible sections that you can look at. So your queue, so the average number of waiting between steps and the hour. So again, this is you figuring out how long each step takes and working on that. Your work in progress or your backlog. Do you have a huge pending work by age? Is samples sitting for an extra 30 minutes, 20 minutes? Your capacity reserve. So again, we talked about the staffing, the instrument capacity. Are you using your instruments to its full capacity? Staffing. Do you have staffing in the right time, the right location? Your rework and repeat touches. So it's really important to understand, are you doing any manual interventions? Is there redraws? And then peak clustering. So is there arrival or results being concentrated at specific time during those shifts? And one easier one, if you're not monitoring it, is the overtime. Is your staff doing more overtime? And then your supply risk. Do you have any emergency orders? How often do you put emergency orders? Are you putting an emergency order every week? That's not a mentality you want to be in. You want to really make sure you have on-time supplies instead of constantly making an emergency order. And then we spoke about the 90th and 95th percentile tag. So again, these are your outliers. You need to watch your outliers. If you notice that your outliers are skewed and it takes longer for those 10% of the slowest and it's creeping up, that means your process is not stable. So I'll have a question for you at the bottom. If a major operational issue were developing today, which dashboard would show it before patients, clinicians, staff, or costs are affected? So this is just a mental question for you. I want you to think about it. What would your dashboard look like? Would it look like this slide or would it be different? Now, where do those signals live? We told you what the signals are, but how do you get access to these signals? Where there's a few different areas. Your LIS system, your lab information system, has event logs. So that's a good start off to see. So if you're using any type of software in the lab, look at the timestamps. When is the sample received? When it's accessioned? When is it resulted? Your middleware or your rules. So middleware is that software that sometimes sits on the instrument. Is there any specific rules configured? Some middleware has specific rules where it holds the results for 30 seconds before releasing it. Your analyzer. Look at your instrument logs. Is there errors? Is there a throughput issue there? Those are all rich data that you might have at your fingertips. Your specimen tracking. How many times is a sample being touched before it gets resulted out? Your staffing and your scheduling. This is an easy one. Look at your schedule for your staff. Are you making the schedule every week or is it every 2 weeks? Is there any spikes in volume and there's no staffing there? So let's go back to that example. If your staff comes in at 8 o'clock, but you have a spike of volume that comes at 7 o'clock, that means those samples sit there for about an hour before they get touched. So again, this is a challenge that you want to look into. And your dashboard, what's your current dashboard? Is it just busy signals? Is it things that you can look at and you can observe? So we'll have another question here for you. Which leading signal do you actually track today? Is it specimen backlog, the slow 5%, repeat testing, or analyzer drift? We'll give you guys a minute or so to answer. Right, so far it looks like specimen backlog. All right, so it looks like about 62% said specimen backlog, about 10% said the slow 5%, 11% said repeat testing, and then 18% said analyzer drift. So if you didn't pick any of the other ones, star it and then think about whether it's worth tracking or not. So let's go back to that example we looked at earlier. You have a queue that's growing. So your turnaround time looks fine. It's green. There's no complaints. There's no QC issues. Life is good, as they say. But there's an early signal happening here in the background. The queue length is actually increasing hour by hour, day by day. And you're not noticing it because you're saying, well, The turnaround time is fine. It looks green. So an action you can do here is you rebalance the staffing. You add an courier drop-off. So instead of the courier coming in once a day, they're now coming in twice a day. So when the queue climbs up, it turns into a service level slip. So imagine that instrument goes down and then immediately you have a backlog because you didn't notice that increase in turnaround time. Now let's look at a stable average turnaround time hides behind that tail. So we said your average turnaround time looks great. You are averaging 32 minutes from accessioning to results. But your 95th percentile, that 5% slowest, it's slowly increasing week over week, month over month. And again, you're missing that outlier. So you need to review that. You change the shift. You realize that some instruments are not being used as much. The process that you reviewed early on reveals that samples are sometimes sitting an extra 5-10 minutes. And an extra 5-10 minutes in the lab world is hours. So the tail moves first, and then the average only confirms the problem. So next time I want you to look at your 95th percentile, your 5% or your 10% of the slowest samples. Are they increasing in time, increasing week over week, or are they stable? So this is kind of an illustrative case. So I want you to kind of think about how your lab can have an opportunity here. So one of the labs I kind of worked with in the past, we were able to find out the turnaround time looked fine, but that 10%, that 90th percentile, was actually creating the issue here. So we were able to kind of shave off some time from 68 minutes to 54 minutes. And we did that by a few different things. We've understood that the staffing model we had was incorrect. We were having staff come in 30 minutes too late. So instead of coming in at 8, we had them come in at 7:30. And the staff was extremely happy. They were able to catch up. They didn't feel like they came in too late. And that really helped redesign that workflow. Recollection. Fixing the two worst collection sites can easily drop down your recollection effort from 4 to 2.6%. One thing we noticed that the phlebotomy team specifically was actually taking longer to get these different clinics. And we realized that the way we were sending the phlebotomists, we were sending them to the farthest one first versus the closest one. So we changed the setup of the phlebotomists where we had them balanced a bit more. So we had some of the phlebotomists go to the farthest clinics and some of the other phlebotomists go to the closest one first. So we weren't wasting time just traveling. Overtime. If you're not measuring overtime right now, I definitely would recommend measuring your overtime. Overtime is any of the hours that a staff works outside of their scheduled time. So if your staff is scheduled for 8 hours, but they're working 9 hours, that 1 hour is that overtime. Or if it's 10 hours and it's 11 hours, that 11th hour is the overtime. Overtime tells you two things. That your staffing model may not be good. If people are staying late, that might be an issue. 2, the work may not be appropriate. So one thing we always try to aim is having the overtime less than 3%, for example. You can't have a lab with 0 overtime. Sometimes things happen. People go on vacation. There's emergencies happen, and you don't have all your staff. So overtime sometimes is not an issue. What happens is that if you constantly have overtime, that is when it becomes an issue. And then we talked about time to discovery. So you implement this type of system, this operational intelligence into your lab. You can really cut down the discovery from an average 3 weeks to 4 days. You can immediately spot the problem and immediately act on it before it costs you money, before it impacts patient care. So as promised, I try to pull a few warning signals for you. So this is not an exhaustive list. This is just about 9 or so issues that you can look at. So on the left side is a scenario, in the middle, what looks fine, what is the traditional indicators. And in the middle or toward the right is the early signal to watch. So this is that new leading signal that you're looking for. And on the right side is the leading indicator, is the indicator you want to look for. So let's take a look at the first one. Staffing mismatch hidden by overtime. So there's a lot of overtime here, but your turnaround time is green. Work is getting done. But your early signal is the overtime percent is high. So this is again where you want to go back and look at your overtime percentage week over week. Is it increasing or is it decreasing? And then your staffing variance. Is there more people on one shift than the other? Let's jump down to molecular testing backlog. Your daily turnaround time is within target. You're getting all the results out. But you notice your work list is constantly growing. There's carryover from one shift to the other shift. There's always spillage. So the morning shift might leave another 20 samples for the second shift. And then the second shift now has to leave another 10 to 15 samples for the night shift. So you want to look at your work in progress backlog. Now, one I want to look at is the specimen rejection and recollection. So again, your turnaround time looks good, but your rejection, your hemolysis, samples, clotting, it's all increasing. So you want to get in the habit of reviewing this early on. So from the examples to action. So again, you want to define the failure mode. You want to identify that leading signal. You want to set a review cadence. So you want to do daily huddles, weekly reviews, monthly capacity. This isn't a system you design and you forget about it. You want to be active here. And you want to assign roles. Who's the owner? Who's acting on what? And then you want to close the loop. So you want to make sure you go back and say, is this signal worth it? Should I invest more time in this signal? And then set some thresholds that make sense. Watch the tail, that 90th, 95th percentile, your baseline by context. Set limits per shift. Trends, you want to look for trends, not just spikes. So if you have one or two spikes, that's not an issue. But if you notice a certain spike every day around the same time, that's an issue. And you want to be persistent. You want to collect data for several consecutive periods. And then you want to pair every alert with an action. If nobody owns it, nobody's going to do anything. So again, we talked about how most labs live between 1 and 2. They're firefighting. We're watching the outcomes. So we need to shift into that reading the signal, that hidden signal. You want to design issues to surface up, not just stay hidden. And who owns the early discovery? So this chart might be applied to certain labs, but not all of them. So leadership, you as the lab leadership, you might be making the leading signal and you're protecting the time to act on it. Your supervisors or your team leads will be the operations. They run the daily review. If you have a quality person, a quality specialist, for example, they're connecting those signals. And then the data informatics is the ones who are pulling the data for you to look at. So the instrument logs, the alerts, etc. And the objection you hear. So sometimes you're trying to implement this and somebody says, we get too many alerts. So this is where you need to start with one signal. Don't go after everything. Just start with one signal and act on it. We have no data. Well, we just disproved that. You have tons of data. It's just a matter of finding the right place to look for. You might say, not my job, but you need to name someone. And you might say, we have no time. We're just so busy. But again, we just spoke about how waiting until it becomes a big issue, a big problem, costs you more time and more money. So for your next 90 days, find a signal. Again, pick one failure mode, one signal, build up the review, put that signal on a visible dashboard, and then go back and review it. Remember, set that cadence, your daily review, and then go back and measure it, and then decide at the 90-day mark, is this a signal I want to keep, or should I change it to another signal? The key here is to pick one signal. Don't try to go after everything. So we got one more question. What's one change you'll make first? All right, looks like we're getting some answers in. I think add one signal is the top one, 42%. Name an owner, set a threshold, schedule a review. That's very important, making sure you set a cadence and go back. So here's your 5 steps for Monday. Pick one signal, set the threshold, name the owner, book the review, and close the loop. It's as easy as 1, 2, 3, 4, 5. Now, I want to kind of end this talk with this statement. The goal is not more data. The goal is meaningful signals reviewed early enough to act. If a major operational issue were developing in your lab today, would your current dashboard identify it before it costs you patient care, the workflow? So again, this is a question I want you to think about. So you want to create a better operational intelligence, not just faster investigation. And then the takeaway. Again, you want to discover lag's reality. Green isn't always healthy, and operational data holds the signal. So again, making sure you understand where that data comes in. And then you want to design beats that detection. So the design of your dashboard needs to be able to bring those hidden signals up to the surface so you can monitor it. And I think that's the last slide there.
Thank you very much, Zahid. And thank you for sharing your experience with us. If you can just perhaps check in the Q&A, there is 2 questions. I think Fred's question is partly a remark, partly a question, because some of it you have already covered in your presentation, but perhaps you just want to comment on it. He says, if root cause analysis only starts after a turnaround time breach, and most laboratories monitor turnaround time using daily, weekly, or average-based reports, are we actually managing turnaround time or simply investigating yesterday's failures? What can we do better? So you have now shown us on the signals, but perhaps just if you want to remark on it.
Sure. So again, the goal here is to kind of find those hidden signals. So this is a great way to look at your 90th or 95th percentiles, those 10%, 5% of the slowest samples. So again, we want to look at the outliers. Is the outliers increasing in time? I think, Fred, you kind of hit it on the nail there, is that we can do better. And the question is looking at the right signal.
Thank you. And then there's from Lamek is asking, from your experience, what's the major factors that affects turnaround time?
Really, the main thing I notice is the lack of understanding of your workflow. So you really need to understand your workflow. And I went through the chat and I saw the right answers for the phases of the lab. So you have pre-analytical, analytical, and post-analytical. So understanding how that workflow between those 3 steps. So again, taking the time to actually have the steps outlined. What happens when you're collecting from your patients? What happens when the samples get into the lab? And from the lab, how do they get resulted out?
And then one last, if you can perhaps just one last question. What is the role of the incident log in resolving delay discovery in the laboratory?
Good question. So your incident log gives you an idea of what these issues are. So if you have an incident, for example, where the QC is constantly out, or the instrument needs another maintenance, a daily maintenance, you might have to start thinking, well, is there an issue with the instrument? Because this type of incident is constantly being logged. So again, you want to look for themes. You want to look for the same incident being logged over and over. If it's being logged constantly, then there's a bigger problem happening under the surface.
Thank you. There's more questions coming in, but we are running out of time. So I don't want to keep the people up that needs to go now. So we will share these questions with Zahid, and then we can share it with the attendees after the event in a written format. And then I also want to just ask you, when you log out, there will be a survey. Please complete it so we can understand what we do well and what we can still improve on going forward in our events. The recording will be made available to everybody after the event. You will receive an email that will inform you about that and also about the next upcoming events. So please register for our upcoming events as well. There is also the recordings you will also be able to access with the same link that you joined today's event as well. So please, if you enjoyed today's session, share on LinkedIn what your key takeaways are, and don't forget to tag Zahid and Labvine, and we hope to see you at the next events. Thank you very much, Zahid, for taking the time to come and talk to us today. I hope we can get you back again, because I think there's more questions and more to discuss. And I also thank our attendees for making this an engaging session. So go well, and we see you next month.
Thank you.
Thanks. Bye.
Bye.